for later. Okay. So one example I'm going to give, we're going to have a missing side, a missing leg. And the other example, we're going to have the missing hypotenuse. So the hypotenuse is the most common. Missing hypotenuse. I'm going to call him hype for short. This one we're going to miss a side. Okay, I'm going to give you a second to draw these because we are only doing 2 examples. And I want to make sure that they're good in your notes. Thank you for taking notes. People are always sad when I say we're going to have an open notes test, and they're like, oh, I don't actually have any of those things. All right. When they're right triangles and we have missing parts, we can use the Pythagorean theorem, which is? So the first thing that I do is I circle the hypotenuse. You don't want to accidentally plug something into the wrong spot. And I always underline the legs. I'm very consistent with that to make sure I put them in the right spot. These are easy to solve once they're in the right spot. So I circle hypotenuse, underline the legs. You can shut that if you want to, Sarah. Okay, then I plug things in. Miles, what do I do now? I'm trying to find the hypotenuse. Yeah, use the order of operations. So we're going to square these. Your calculator can do that for you. If they're easy, maybe try them by hand. Okay, today's homework is big ideas. And sometimes it says to give the exact answer. So we're going to talk about a couple ways to do that. Macy, how do we find x if we know x squared? Divide it. What's the opposite of adding? Everyone, what's the opposite of adding? What's the opposite of multiplying? What's the opposite of squaring? Square root-ing. Square root-ing. These are opposites, so they cancel out. Now, if it says to you that you need to write your answer as a reduced radical, well, we might need to review that. If you just punch this in your calculator and you get a decimal, but Big Ideas asks for a reduced radical, we need to probably review it. We came from 4 or 5 different teachers. I'm not sure how they taught you to reduce a square root, so I'm just going to show you my method, and hopefully it'll at least remind you how they taught. I prefer to do a prime number factor tower. The factoring tree works, but kids lose numbers all over the place. So the only thing that can go on this side is prime numbers like 2, 3, 5, things like that. If they're even, I know that 2 will go into it. And then I factor this. 13 is a prime number, so he gets to come on the prime number side, and I know that I'm done. If you do a factor tree, it's going to look similar. You just got branches coming all over the place. Zara, why am I doing that? Yes, this represents the square root of 4, which is 2. And the square root of 13 just stays like that. So if the directions say leave your answer in exact form, they want the square root of 52. If the directions say to reduce the radical, they want 2 times the square root of 13. And if they say round to the nearest tenth, you can put it in your calculator and come up with the decimal. I think this one was 7.21. So again, this might be the hardest part if they ask you to do that. The Pythagorean theorem, not too difficult. Okay. The only thing hard about finding a missing leg is if you don't notice that's what you're trying to find. So you put it in for a C. That's the biggest mistake people make on this one. So I take a second, and that's all it takes. Circle the one that's in place of the hypotenuse. Underline your legs so that they go in the right spot in your formula. So Levi, where will the 12 go in my equation? Will it go in for A, B, or C? Yes, because it's the longest side. It's the hypotenuse. I had some students trying to do some shortcuts on their calculator. She was like, I typed in the square root of 12 squared divided by 8. I was like, I have no idea what you're talking about. Do a couple steps before you're subtracting. Don't try to do too much in your calculator. Like, do it in pieces. It's okay to square it. Yes. She was typing in the squares and not doing parentheses, and it was squaring the wrong stuff. I don't know. It was kind of a disaster. But yes, I would definitely square and then subtract. Yeah. You can. But if you don't have parentheses in the right places, you're not going to get the right answer, is what I'm saying. The calculators don't know the order of operations unless you tell it what to do. So what did you get for 144 minus 64? And now we remember that the opposite of squaring is square rooting. If it says to leave your answer in exact value, you leave it as the square root of 80. If it asks you to round to the nearest tenth, punch it into your calculator. If it asks for a reduced radical, I like the factoring method personally. So what goes into 80 that's a prime number? I always start with 2's. 2's are easy. If it's even, it's 2's. 2 again, 2 again, 2 again, prime number. Now, I'm not trying to teach this. I'm trying to just review it. I'm going very quickly on this prime factorization. Why am I circling these? There's 2. They represent the square root of 4, and the square root of 4 is what they represent. Yep. Reduced radical form. So Pythagorean theorem, pretty easy. Reducing radicals, not quite as easy. Okay, so again, when you see the Pythagorean theorem or right triangles and they ask you to find a missing side, make sure, Ashlyn, are you working on the assignment already? Please shut it. Make sure that you put them in the right spots. Okay, so make sure, like Levi said, if it's the hypotenuse, put it in place of the C. All right. Is it a right triangle? There's going to be times when they just give you 3 numbers. And they ask you, could these 3 numbers be the sides of a right triangle? Here's one set we're going to try. And just because it looks like a right triangle doesn't mean it is. We have to test it out. So I'll give you a second to write these 2 down. Hey. Thank you. All right. Kate, how do you think I can tell if this is a right triangle? What am I going to do to figure it out? Yeah, so let's plug them in. Now, the reason why I drew a picture for this one is because I don't think I would know that 2 times the square root of 29 is bigger than these. It would take a little bit more work than I want to do. So that's why I gave you a picture. But the main thing is make sure that the biggest side is in place of the C. And then type that in your calculator. Type that in your calculator and see if they're equal. Are they? So everyone give that a try. Some of you can't really tell. Like this one's hard to do in your head, I think. You don't have to. Just push enter. And then try this one all by itself, and then you just kind of match them up. Prime numbers can only...
Set one in itself to equal. So it's like 2, you can't multiply anything. That, like, except that, like, a whole house. Like 3, you can't multiply anything. 5, can't multiply anything. 11, 7.
It's a number. It's a number that can only be divided by 1 and itself. It's like 5. The only thing I can divide 5 by to get a whole number is 5 or 1. But like 6 and 1, but also 2 and 3. So it's not prime. Okay, Jeremy, what did you get when you did 10 squared plus 4 squared? 116. What did you get when you did 2 times the square root of 29? Squared. Jeremy, did you do that one also? So is this a right triangle? Yes, they are. Yeah. You have to go sharpen it. Mm-hmm. Okay, did you guys try this one? I know 12 squared is 144. And this is 121. And this is 9. Are they equal? So you just put a slash through it. They are not equal. No, this is not a right triangle. If it was, the Pythagorean theorem would work on it. Okay. We talked about a minute ago a Pythagorean triple. Please write that down. I want to make sure we understand what it is, because it asks for it all the time in your homework. Pythagorean triple. You know one of them? Is there not supposed to be? No. Thank you. It's okay.
I do that a lot. Well, not triples, they're like a lot of work.
Does anyone remember the example from a minute ago of the Pythagorean triple? What was it?
4, 3, 5.
Yes, a 3, 4, 5. If you put these into the Pythagorean theorem, they work. 3 squared plus 4 squared is 5 squared. So on your homework, it's going to have you find the missing side. Then it's going to ask, is this a Pythagorean triple? So you're just looking for whole numbers. They're all 3 whole numbers. And they work in the Pythagorean theorem. So I want you to check one more. We'll do 8, 15, 17. Is this a Pythagorean triple? So you're going to try 8 squared plus 15 squared, and you're going to see if it equals 17 squared. So give it a try. So again, on the homework, it'll say, find the missing side. And then you find it, and then it'll say, is this a Pythagorean triple? And so we are just looking to see, are all three of them whole numbers? Kate, did this one work? So yes, this is a Pythagorean triple. Is this one a Pythagorean triple? No. Why not? Yes, they worked in the Pythagorean theorem, but the hypotenuse was not a whole number. These are all whole numbers. Is this a Pythagorean triple? Why not, Logan?
Because it doesn't make a right triangle.
Yeah, it's not even a right triangle. Okay, there's one more thing, and as far as I know, this is new across the board. Nobody has seen this before. Please write it down. If you haven't written anything else down, you need to write this down, or there's going to be 3 or 4 problems in your homework that you won't have the skills to do. The classifications of triangles are obtuse. Not this, not the vocabulary words. You are going to be given 3 side measurements. And they're going to say, do these 3 sides create an obtuse triangle, an acute triangle, or a right triangle? We know what this one would look like if a squared plus b squared equals c squared. You would choose a right triangle. We know that one. We've just practiced a bunch. If you plug them in, like we did a minute ago, the one that was not a right triangle, I think it was like this. A squared plus b squared was less than c squared. If that happens, it's an obtuse triangle. And you haven't learned that before, that pattern. This is a new pattern as far as I know. If you plug the sides in, an a squared plus b squared is greater than c squared, you have an acute triangle. And I don't know if you can really tell ahead of time. It doesn't take long to figure it out, but you can't really tell ahead of time. Okay. The assignment is not very long, but you have the rest of the time to work on it. So go grab your computers. Oh, you have very long arms.
Oh, yours is fancy.
Yeah.